Whenever you see a complex data frame and you just want to find out patterns in that complex data frame, you will be going like, bro, what's that? But when you transform that same data into visual plots, you will become like, oh my god, it's really aesthetic. And in this video, I am gonna teach you that art of visualization in just a few seconds that you will understand and you can apply it in your own life, on your own data. So for this video, I'm gonna be using the Matplotlib, which is a very basic library, and it is very popular among the data scientists, AI engineers, and many Python developers. Maybe I use other libraries like Seaborn, Plotly, Bokeh, etc. But that will be maybe in another video. So please subscribe to my channel in order to be notified for every new incoming videos. So here I am in the VS Code. First of all, let's just import our libraries. So in this video, I'm going to be using the Matplotlib and NumPy for converting arrays into that visualized structures. So first of all, import NumPy as np and import matplotlib.py plot as built. So these are the two libraries we will be using over here. So before we move further, first of all, let me just explain you the basic structure of a figure, that what is the most important components of a figure. Let me just give you the very first example from the Matplotlib, its own website. Okay, so this is a very simple anatomy of a figure. Let me just explain each and every part of this figure. So actually this line is the x-axis, and this line from this top to the bottom is just the y-axis. Okay, and the dotted lines that you can see over here, this line and this dotted line, that is just like a grid structure, that just like a net. Okay, so this is called a grid. Then this line over here is just, we want to plot a line, and this is just like the points that is matched on that figure. So, and the dots you can see over here, the purple dots, it is just like a scattered plots that you just want to point out and place point to point on that figure. This is a y label. It means that you just want to give it any name. For example, you just want to compare the age with the fear, or you just want to say like the age with the death rate. So the death rate, for example, if this is the x-axis and the y-axis is just the age, so you will have to give it the name of age in order to, for simplicity. Then we have the small lines and the slightly bigger lines and the small lines. Okay, so these are just called the ticks. Okay, ticks. And the number that 1 2 3 4 are just called the tick labels. Okay, so this is a very simple structure of a figure. Now let's just go towards the art of visualization. So first of all, we need to just create a very simple plot. Okay, so in order to create a plot, we need to just have the two types of data, the for the x-axis and the y-axis. So for this simple plot, I will just want to plot a sine wave. Okay, a sine wave. Simple. If you know a little bit mathematics, so you will know about the sine wave. It is a simple plot for beginner. It's just like a hello world in Matplotlib. So for that, I will just use the NumPy in order to create that data. So how will I just create x and y? So for x, I will just say np dot arrange, and I will just start from 0 and end at 2 pi, because I just want only one cycle. So, and one cycle is about 2 pi in mathematics. So I will say like math dot pi multiplied with 2. Okay, 2 pi. And then I will just say like the distance between each and every value should be how much I want. I just want to say like 0.05 in order to get a precise sine wave. Okay, and the y will become the actual sine value. So I will say that like np dot sine, and I will feed the x to this function, and it will create the sine wave. So we have just got the x and the x-axis and the y-axis. Now we will have to just plot them. So how to plot them? You will have to say like a plot, a plt dot plot, and provide the x and y. Okay, and here we go. This is a simple sine wave plot function. Now you can see that the art of visualization. If you just want to see the x figure, so look at just this data. How would you just take information from this data? If you look at the y, just look at this. this is a whole bunch of data that you can say like it really sucks. So, and when you visualize it over here, you can see over here that it's just really aesthetic thing. Now, if you just want to say like I want to give a name to this figure, so you will just say like plt dot title, okay, and provide the name in that string like structure. So we'll just say like a sine wave, okay, simple. Now you can see over here the sine wave is just appeared on the top of this figure. Okay, you can also name the x-axis and the y-axis and the x-axis. So how would you do that? You can also give it like plt dot x label, which is just like for example, you just want to say like x label. It's simple for just a simplicity. And the y label, I will just say like plt dot y label, and you will say like a y label. Okay, and now you can just create that the y label appeared on the y-axis and the x label appeared on the x-axis. Okay, so this is a very simple plot. Now you just want to say like I just want to draw a multiple plot. So how you can create a multiple plot? For example, this is only sine wave, and you just want to say like I want also cosine wave in this same figure. So for that, you need to just do the another plot. You will say like plt dot plot x. X is sorry, x will be same because we just want that cosine wave in the same structure, so the x-axis will be the same. So just take the x, and for the y you will use the cosine function. Okay, so you will say like np dot cos, and you will just provide the x. And when you see that, now you can see that the cosine function over here, as you know that the cos 0 is equal to 1 and the sine 0 is equal to 0. So this is the cosine wave, and the blue one is the sine wave. Okay, you can also make it more attractive. For example, if you just want to say like I want the blue line as dots or stars, or I just want it a red line. So how would you do that? This is the, which one is the, this one is the sine wave. Okay, so for the sine wave, I will, you will use comma, and after that you will provide it in a string. In a string you will first have to need to specify the color. So for example, I just want it red, and then you will just have to specify the structure, which kind of structure you want. So if I just want the star structure, and then when you print this, you can see over here that the sine function is converted into red star dotted lines. Okay, and for the cosine function, I just want to say like I want it yellow. So comma, and provide y. H is actually hexagonal structure. It is not like a circle but hexagonal structure. And when you run this, you can see that this is a hexagonal structure. Okay, now you will say like if I show this to someone and I'm not with him, so how will he notice that this line is about the cosine and this is a sine wave? So you can also add the legend for that, and the legend will appear over here, which will say that this line is about the cosine and this line is about the sine wave. So how would you do that? You would just say like P- plt dot legend, and after legend you will just provide the that names. So first of all, we have the first figure, we have the sine wave. Okay, and the second one is the cosine wave. Okay, and when you print this, you can see that the sine wave is this one and the cosine wave is this one. So what about the location of this legend? We have just provided nothing, but when you say like location for log equals um for example, I just want to say like upper left, and then when you print this, so now you can see that the legend is transformed, and it goes towards the upper left corner. You can use all of these locations. So this is a symbols that you can use instead of this only and only star. Okay, so you can also use all of these symbols, and for the color you can use this black, green, red, yellow, etc. So this was a simple multiple plot. If you just want to say like I don't need this cosine function over here. I just want a cosine function that is a separate figure over here. So how would you do that? You just want a cosine function in another box, but that box should be is same in this figure. How would you do that? You would just have to take a figure and you will specify the axis. So you will say like a figure equals plt dot figure. Okay, and then you will have to just define the axis x1, for example the axis one, which is for the figure number one, and you will just say like a figure dot aid axis. Okay, and then here you will just give it the axis. Okay, okay, these are the axes for the figure number one, and for the figure number two I will say like figure dot aid axis, and here you will provide the axis. The first one is the length along the x-axis, and the other one is the length along the y-axis. Okay, third and the fourth one is about the size of that figure, and you should note it down that all of these data and values should be between zeros and one, and the remaining things are just a simple. So I will paste it over here, and you can see over here that the ax1 dot plot, so x and y, I've just provided the x and y. Okay, and the for the second one, so I have just converted into the cos function. Okay, and for the first type, for the first figure, you will have to just say like this is a sine wave and the second one is a cosine wave. Okay, so now print it. So now you can see over here that this is a cosine wave in a valid structure, in a valid separate structure, and this is the sine wave. So this is how you can create a figure in inside another. Now if you just want to create multiple plots, or you can say like I just want in these figures multiple plots but separate plots, so you will say like subplots, which is called the subplots. So for that purpose, subplots. Okay, so for that purpose, you need to just we have a function called the subplots, and how would you use that? You will just say like a figure and comma x equals plt dot subplot plots, and after that you will have to just give how many plots you want. So for that purpose, you just first have to give it the number of rows. Okay, and how many rows you want that figures. So for example, I just want two rows and two columns. Okay, so it is just like four figures in two rows in two columns, so just like 2 by 2 matrix. So if it is 2 by 2 matrix, so it will have four elements. So if it has four elements, so here it will have four figures. Simple. Then we have to just give it the figure size. So for the figure size, you will just say like brackets, and here you will just give it, for example, 4 and 5. This is the size of that figure. Okay, and now here you will just add something to that axis. For example, if you just want to say like axis um 0 1, what I've just did over here, I'm adding axis to this figure, and one, so this is a first element, sorry. So you will just say like 0 0, because the column the row is 0 and the column is also 0, so this is the very first element of the figure. And I will have to say like dot plot, and here you will just give it the x-axis and the y-axis. So I will just provide the x, and for the y-axis I will have to just take a square of that, so x square. Okay, so this is our first plot. Now copy it for another one. So these are the four plots, and when you print this, here you can see that these are the different figures. Okay, that we have just created from that figure. So the figure is the same, but if you just want to change the figure size, so we'll say like 8 8, and now the figure size has just changed. Now it looks better. Now you can also create a grid like structure over here. The grid like structures mean that when you want to have, for example, if I say like plt dot grid, okay, you will see like there is a grid like structure over here. but this is only in the in one figure. But I just want to explain it more accurately and how you can customize your grid like structure. So for that purpose, I will just have copy paste some of some lines and I will explain it. Okay, so here I am just creating a figure and defining the axis, and here I am just taking the subplots, and in that subplots I am just defining that there will be one row in that figure and there will be three columns. I just mean there will be three figures in a row. Okay, and the figure size is 12 4. Okay, and then I have the array, and that X array is just taking values from 1 to up to 10. If you don't know about the numpy, you can just watch my video on this. So I am just taking x is 0, and x is 0 means that it is just the first element of the row. Okay, and I'm just plotting x power 3, and the g over here is just saying that the line will be green, and the lw is just the line width. Okay, the line width is 2. Okay, then you can increase it or decrease it, and I have just said that x is 0 dot grid equal true. Okay, I'm just taking um uh I'm just creating a grid for this, and then I saying like x is 0 dot set title default grid is just a by default grid. Okay, and then for the second figure I'm just saying that x is 1 dot plot np dot exponential. I'm taking this x and taking exponent of this. Okay, applying the exponent, and I'm just saying that red, the color will be red of this second plot, and then I'm just creating a grid of for that, and the color will be blue. The color of the grid will be blue. I'm just customizing the grid. So in order to customize the length structure will be dotted line. Okay, the dotted line, and the length width will be 0.40. You can increase or decrease it. Okay, as you wish. And then I've just set the title for a custom grid. Okay, for this figure. Now the third figure is I'm just only creating this x, and the y-axis is also the same line, so it will just like a straight figure. Okay, just like an aeroplane. Then we have just set the title as no grid, just for educational purposes, that you can understand that what's the difference between these grids. And when I show you this. Okay, so as you can see over here that the first title is having a default grid, and the second title is a customized grid, and this is having no grid. So this is a little bit about the grid, that how you can customize your grid. You can also create a twin plot. How would you create a twin plot? Twin plot is just like, for example, you have one function which is having some sort of structure like this, but you just want another function, and you just want to say like this should be correlated to each other. So for example, if I just have this code, for example, okay, and I just want to say like this is an x array. Okay, simple. And I just want to plot a figure, simple figure, and I just want to add axis to it. This is the axis, simple. And I just want to say like plot np dot log of x. I'm taking the log of the x values that is present in the x array. And for the second one I'm just calling ax, the axis number 2, and I just want to say like ax1 dot twin x. Okay, what I'm just taking over here, I'm just saying that like the x-axis will be twin to both figures. Are you getting me or not? The x-axis for both figures will be just like a twin. It means that it will be common to both of these figures. The axis 1 and the axis 2. Both of them will be having the same figure. And I'm just saying that like axis 2 dot plot np dot exponential. This is the log of x, and this is the exponent of x. Okay, so both of them are not the same thing. And here I am just providing the color and customizing the line, so red and dash dotted line. And I'm just creating the legend, which are the actually the label, and the first one is the log x and the second one is the exponential x. Okay, so you can see over here that this is the log of x. Okay, and this is the exponent of x. So the twin plot is actually comparing two plots, that if you have a similar data and you just want to apply different functions to that data, so how would they correlate to each other? So this is how you can correlate both of them. You can also create a histogram or a bar plot, for example, like this. For example, I have a figure and I have just added the axis. This is the axis, and these are, for example, I have just a data for the languages. Okay, so C, C++, Java, Python, PHP. Okay, these are the different languages, and I have the student for each. For example, the C has a student 23, the C++ has a student 17. So it's just kind of sucking data because it doesn't look like, aesthetic. But when you want to just convert into bar plot, so it will become aesthetic. For example, I just want to click it, so you can see over here that C++ is having this one, and you can also indicate that the Java is having the most students. Okay, and the Python is having the second most. Okay, in order to make it more informative, you can also add the line chart to it. For example, if I just say like ax dot plot. Okay, and in that plot you will just provide the lengths and the students. Okay, and provide the structure to it. For example, I just want a red line, and that will be just like o structure. And then when you print this, so it is also printing the dotted lines to it. So it is just like showing the ups and downs in this figure. Okay, thank you and have a nice day. So this was a simple introduction of the Matplotlib and the very, very basic figures that is present in the Matplotlib. I hope you have got something new in this video. If you want me to explain more Matplotlib figures and the more complicated figures of the Matplotlib, so you can tell me in the comment section below. Thank you and have a nice day.